Howdy, it's Mr. Justice. We're going to talk about the greenhouse effect and the carbon cycle. All right, so hopefully by the end of the process, you will be able to explain how the greenhouse effect works, and we'll explore how anthropogenic activities can impact biodiversity. All right, so here's the greenhouse effect here. So here's how this goes down, all right? The light from the sun travels through space, 90 million miles, to get to Earth. The light warms up Earth. Some of it gets deflected right back into space, right? It might reflect off of white clouds or snow. But some of the light does get to Earth and warms up the Earth. The Earth then re-radiates out that light in the form of infrared light. It's heat, thermal energy, heads back out into space. Now, the greenhouse effect is a completely natural process. It's a good thing. If it didn't happen, our temperatures would fluctuate wildly, right? It would be very cold, in fact, here on Earth. And so the greenhouse effect, what it does is that as that infrared thermal energy re-radiates back out into space, it encounters some greenhouse gases along the way. Temperature is a measurement of the average kinetic energy of particles. And so as that thermal energy pings off of and collides with some of those greenhouse gases, they begin to vibrate and move just a little bit more and re-radiate out some of their thermal energy too, right? And so on and so forth. And so as that happens, then that thermal energy is kind of kept closer to the Earth, kind of the same way that a blanket might keep you warm in your bed. This blanket of greenhouse gases in our atmosphere keeps us warm here too. So I've got this great video here that I found, right? How does the greenhouse effect work? This is going to go through it. The greenhouse effect explained. Now, since this is a video lecture, I'm not going to play this video because you guys are all able to do that on your own. So how can you access it? Go to crjust.us/GHE. And that will bring you to this video. It's about 3 minutes. It's really awesome. It'll bring you through this concept right here on the screen. The greenhouse effect is a natural process that warms the Earth's surface. When the sun's energy reaches the Earth's atmosphere, some of it is reflected back to space, and the rest is absorbed and re-radiated by greenhouse gases. The absorbed energy warms the atmosphere and the surface of the Earth. I wanted to show you guys this, the greenhouse effect right here. So I'm going to come over to my gizmo. All right, so here we are. So take a look. I've got, let's take a look at the graph, right? We're going to build a graph here when I push play. So we've got this system here, and I can increase or decrease the amount of greenhouse gases within this volume of space, right? Think about what the greenhouse gases do. They're able to absorb some of that thermal energy that's coming out of the Earth, getting warmer, right? So think about what's going to happen if we increase the greenhouse gases in our system. What will happen to temperature over time, right? You're probably thinking that as we increase these greenhouse gases, we will also increase the temperature too. So let's see if that is true. So I'm going to push play. You're going to see here that in our simulation, the sun comes up, and notice how the temperature increases. And then when the sun goes down, the moon comes up, right? The temperature decreases. So we've got this, on that green line, this cyclical increase or decrease. So right now, though, like if we found the average between those peaks and those valleys, we'd probably be at a pretty constant straight line. So let's see what happens to the trend of that line then if I start to increase these greenhouse gases, and we speed up our simulation a little bit too, so it goes faster. And you're seeing now, right? There we go. That moves for me. Right now you're starting to see that uptick of that slope of the line, right? As we increase temperatures all that much more. So let me push pause here on the sim, and we'll go back to the slides. So this is the carbon cycle here. We're going to learn a little bit more about the carbon cycle, but CO2 exists in a little bit less than 1% of the gases that make up our air. 78% nitrogen gas, about 20% oxygen gas, and about 1%, a little less than one, actually a lot less than 1% of it is carbon dioxide. And that carbon dioxide plays a really important role actually for our life, right? Because plants are able to take in carbon dioxide from the atmosphere, fix it into glucose sugars, which they intend then in turn use for respiration and growth, right? Meanwhile, animals, are also able to use that food from the plants and consume that through their own respiration process. And that returns the carbon dioxide back up into the atmosphere in this kind of nice cycle here, right? Between photosynthesis taking in CO2 from the atmosphere to make carbon-containing organic sugars, and then respiration, which uses those organic compounds, those sugars, as energy source, and then the waste product is carbon dioxide, which kind of keeps going in and out of the biosphere into the atmosphere and so on, right? And that's why you see this equal sign. So about the same amount of carbon dioxide comes into the biosphere, the plant life, at about the same rate as it leaves. Hey, if there is any extra here, it can be stored within the ocean. The ocean is a carbon sink. It's a reservoir of carbon. Notice that it is able to exchange and dissolve some of the carbon dioxide out of the ocean, but notice that there's a little bit more here of the carbon dioxide that is brought in or dissolved into the ocean. When that happens, it forms carbonic acid, and carbonic acid is an acid. An acid. It lowers the pH of the ocean. The more carbon dioxide dissolves into the ocean. And so what's upsetting the balance here, right? If everything is kind of being accounted for, there's one aspect here that isn't, and it is the fact that there are these fossil fuels, these carbon-containing fossil fuels in our ground, right, that are pretty much permanently stored, sequestered away. And if it weren't for human anthropogenic activity of extracting those fossil fuels, combusting them, and then producing the carbon dioxide, that wouldn't happen normally, right? And so that's what you're seeing here, is that this massive amount of carbon dioxide enters into our atmosphere at a rate that is not natural, at a rate that can start to cause some problems. So you got to remember, right, the more greenhouse gases, which carbon dioxide is in our atmosphere, the warmer the temperatures are going to be, right? An increase in carbon dioxide and other anthropogenic greenhouse gases like methane or nitrous oxide or water vapor in the atmosphere can enhance the Earth's greenhouse effect, making global temperatures warmer. The greenhouse effect is a good thing. An enhanced greenhouse effect increases temperatures and can cause some problems with our biodiversity here on Earth. All right, so in class we did an experiment, and I wanted to show you guys the results. You're going to need this information, this data here, to be able to do the greenhouse effect CER activity. All right, so look for that underneath our day 18 activities too. If you were with me, you saw that we went outside and I took 2 thermometers, right? And one thermometer was on black paper, and the other thermometer was on black paper, but in a bottle, right? And so what we're doing here is we've got a control group and an experimental group. What we're interested to do is we're kind of simulating the greenhouse effect, right? Think about what the experimental group is here on the right. The bottle is going to represent the atmosphere itself, right? It's the greenhouse gases. It's kind of this idea of trapped blanket of gases within this bottle. In our control group, the one that's not going to have the bottle, notice that there's no trapped gases here. So there's a lot less volume of gas. Let me say it again, less gas per volume here on our control group than over here on the experimental group, where there's a lot more gas per volume. It's trapped in there, and we're going to see what happens in terms of the temperatures, right? Make a prediction right now. Which one do you think is going to increase the most, right? You're probably thinking the experimental group. I want to mention one more thing here, because you're going to need this information to fill out that CER organizer, is that this black paper here is actually pretty important in our design setup. It simulates Earth, the land itself. If you remember our discussion earlier, we need something on our Earth that will warm up, right? So this is what's going to happen here. When I take this outside, the sunlight is going to warm up this black paper, not unlike how it does it to the earth too, right? And then re-radiate out that energy in the form of thermal energy. So yeah, that's, notice that there's a black paper over here too. So again, we needed something to absorb the light energy from the sun and re-radiate out that thermal energy to be captured by these thermometers. And here are the results. All right, so we let it hang out in the sun for about 5 minutes or so. And if you look, it looks like the experimental group, the one that was in the bottle, was about 34.5 degrees Celsius versus the one that wasn't in the bottle, a lot less gas per volume, which was about 32 degrees Celsius. So you're going to need those data points there to finish up that lab, all right? There it is. I forgot I had those nice yellow boxes pop up. All right. I hope this was helpful. Talk to you soon.